No.
It's like different.
Yeah, Math 120, there's, I think we talked about this, there's two different books that people use. So if you're going to take Math 120, as you're looking at the schedules, you should also go to the bookstore and see, do they have books for next semester in the bookstore yet? Do they have them listed like...
We were doing like renovations out there last week.
All right, well, you can always ask me. I know some of the people and which book they're using. I'm not sure about some of the other people. And I think if you look it up on the schedule, or you look up textbooks, they should tell you what book you need for the class now, right?
It should, when you go to your schedule, it'll say details or something, and it'll tell you.
Link you to the book? Okay.
It'll tell you like the course information, and sometimes, depending on who the teacher is, it'll have...
All right. And you go to the bookstore website and just look up the class and see what book, because there's two books. And if you can get into the bookstore, you want to kind of look at each book and see which one feels like something you can handle or you want to work with.
When I met with the counselor to sort of plan out my stuff over the semesters, she's told me since I might go into journalism that stats would be the best one. And I registered for 3 of my 4 classes, and the math one, it wouldn't let me register because there's a prerequisite I got to clear. I mean, I sent...
When's the last time you tried?
Last night was my registration date, and I sent in a request for prerequisite clearance.
Well, he did it for us.
Yeah, it should be clear. So if you're having trouble, I got to ask them to, because we gave them a list a long time ago of everybody and said, clear all these guys, and if you don't pass, we'll just have a little something saying, hey, you didn't pass, guess what, you got to go back. And they would take you out of the class, but you should have the opportunity to sign up. So if you're still having trouble, I got to tell them to go in and check you.
I'm just really worried because I don't want to finally get to it and then it's all closed out.
Exactly. So send me an email the second you can, so I can tell them to check you out and make sure that you're cleared.
Yeah.
You with me?
Will you send them an email today?
Yes, I will.
Thank you.
But from here to my office, I'll forget. So you must send me an email so I won't forget. It's nothing personal. I forget anything. From here to there, it's gone. Okay. What's up? You want a donut?
Oh, no.
All right. I can't help you there. Oh my gosh. All right.
It just came out. I didn't mean to say that.
All right, guys. So, variables in general take the place of something we don't know. So I can put a variable, bless you, I could put a variable as a base with a power on it. We've seen that already, right? I could put a variable inside of a radical if I wanted to. I could put a variable on the bottom of something if I wanted to. Right? So we put the variable in all these different places because I could put numbers in all those different places, so I should be able to put an x in those places because x represents numbers. One place that we haven't put a variable yet is that's a power. Powers, of course, are also known as exponents, and that's why we call this an exponential function. It's a function where the variable is in the exponent. How are we doing so far? So on one level, this is not that big of a deal. We know how powers work, and actually let's take a minute and make sure that we remember how powers work. So let's start off really easy. What's 3 cubed? 27, because you did what? 3 times 3 times 3. So the basic idea of exponentials is the number of things you're having multiply. So what's 3 to the 0? 1. Sweet.
Anything by 0 is 1.
Yeah, anything to the 0 power is 1. I like it. I got no 3's, so I'm left with that understood 1 that's in front. That's really one way to look at it. I got no 3's. So what do I got? I got that 1 that's always there. That's all I got. What's this?
1 more, 1 minute.
Yeah, because what's a negative power mean? Flip it. And then, so if I got to flip it, and then I still have to square it. So it'd be 1 over 3 squared, 1 over 9. So basically, if 4 squared is 16, 4 to the negative 2 is 1 over 16. And think about let me see if I can push this a little bit further. If I take 3 and add -3, what do I get? 0. It's amazing. I get back to what's known as the additive inverse. I get back to the number that doesn't change something when I add it to something. If I take 3 and multiply it by 1/3, where do I end up? 1. I end up at the number that when I multiply it by something, it doesn't change the number. So this negative means opposite, right? But where is that negative? In the power. And what operation or power is about? Multiplication. So it's the multiplicative opposite. So what's the opposite of 9 multiplicatively? 1/9. There's a whole other way to look at it. Okay. Alright, so those are some key things to remember. So if I wanted to, we've already got several good things here. If I wanted to graph this, because somebody like the teacher asked you to for points, maybe, I could start plugging in values. Like if I plug in -2, we just figured out we get 1/9. See that? 3 to the -2 is 1/9. Is that cool? You guys, is that understood? Doesn't have to be cool, just understood. All right. -1. If I plug a -1 in, what's 3 to the -1? 1/3. Plug a 0 in. What's 3 to the 0? 1. Plug a 1 in. What's 3 to the first power? Amazing. I plug a 2 in. What's 3 squared? 9. So then I can graph this bad boy. Let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 1, 2. Okay, we don't need this down here, really. Notice that, can anybody help me out? This, if I go this way, if I keep going this way, 3, 4, 5, what's going to happen to these numbers? The outputs. They're going to get stupid. They're going to get stupid. They're going to get really big quickly. Right? What's 3 to the 7th power? Big. Whatever it is, it's big. You guys, I don't know either, so don't worry. Now what's going to happen as I go this way? If I keep getting more and more negative, lower and lower negatives, it's going to get smaller and smaller and smaller. Is it ever going to get to 0? What's always going to be on the top? 1. 3 to the -18 billion is 1/3 to the 18 billion. Is that equal to 0? Nope. What's the only way a fraction equals 0 is if the top is 0. But the top will always be 1. No. So here's what's happening. Visually, here's what's happening. When I plug a 0 in, I got 1. When I plug a -1 in, I got 1/3, which is about right there. -2, I got 1/9, which is like really stupid close. At least on my scale. Plugged in a 1, I got 3. Plugged in a 2, I got 9. So here's what any exponential looks like. Has that shape to it. So if I were to use the base of 2, all these numbers would have been, these would have been smaller, these would have been not as small. You guys see that, right? 2 squared would have been 4, not 9. It would still have the same shape, it just wouldn't rise as quickly. If I put a 7 in there, this thing would take the freak off, right? 7 squared is already 49. Holy shit, 7 squared is way up at 49. Do you guys see what I'm saying? So, very often, if you watch enough horror movies, you'll find a horror movie where they say the monster is growing exponentially. Or if you watch a virus movie, they say the virus is spreading exponentially. Here it is today, and tomorrow it's here, and the next day it's the world. And you're like, oh shit. You guys with me? I don't know if you ever heard that, but sometimes they'll say that. Yeah. The blob is growing exponentially. I mean, no offense to any monsters out there. Okay, so that's not too bad, hopefully. Let me talk a little bit about... No, let me ask you this. This feels a lot like just a regular like this, x cubed or x to the fourth. I mean, there's obviously a connection because it's both about the power. Here, the exponent is the variable. Here, the base is the variable. You guys kind of with me? So if I said, what squared is 16? What is that? 4. But that's a dumb way to ask that question. Don't we have a quicker way to ask the same question I did? What's the quicker way to ask, what squared is 16? There's a better way to say that in mathematics, isn't there? Square root. Do you guys see what I'm saying? So in math, we don't like this idea of fill in the blank to figure out. No, we don't like that shit. We want a symbol that represents the idea of what I'm trying to get. I want, what do I square to get 16? Right? Or what does it take 2 of to multiply to be 16? 4, yeah. What about if I said, so remember, what's the question you're asking yourself if you get this problem here? What does it take 3 of to multiply to 125, right? Yes, sir. What's the answer? 5. Why is the answer 5? Because 5 times 5 times 5 is 125. I like it. Right? So, I want to develop the opposite function to this. The same way that a square root is the opposite of a square function, I want to know, well, what function is the opposite of this function? And you're like, whoa, dude, we just learned this one. Shit. Well, too bad. So really what I'm saying is, I want a function who does the job of this question. 3 to the what is 9? Now, obviously there the answer is 2. So it's not all about getting the answer. Right now we're talking about how do I represent this question. So why are roots relatively easy? Why do you not have to think too much about it? Because you've already internalized what this question is. Right? There's a question here. And most of math is just shorthand. We don't like to write the whole damn, what does it take 2 of to multiply? No, screw that. Let's just make a symbol and tell everybody that's the question. It means, yay, now it's quicker to write shit. You guys kind of with me? So I want the same thing here. Now, unfortunately, they chose a really weird symbol. They chose basically a word as a symbol. And it comes from the word logarithmus, from Latin, which comes from Greek, logos and arithmus and blah, blah, blah. It's crazy. But so unfortunately, they chose this. But what we have to do is to internalize the question. Don't look at that and say, how am I supposed to understand that? I've never seen that before. Well, there was a time that you had never seen this before either. It's the same thing you got to do. What question is this asking? The same question this is asking. What does it take? How many of these does it take to multiply to be this? 2. Or even better, a little bit better in a way, what power does this need to become this, a second power? So the answer to this is 2, because 3 to the second power is 9. So what's the answer to a log? A power. I like it. So for example, what's log base 2 of 8? What are you asking yourself? This is all about internalizing the question. What's the question this is asking? What is it? How many, or what power does 2 need to become 8? The third power. And how do you check yourself? Well, look, you can always do this. 2 cubed is 8. Check. I just checked it. You can always draw these little arrows. That base to that power has to be this guy inside. Same way you can do here. If I said square root of 49 is 7, how do I check that? There's an understood 2 there, right? So I'd say 7 to the second power is 49. Check. It's the exact same thing. You don't even think about that, though. You just kind of like quickly check it in your brain. What you're doing is exactly that. You're just not as used to this as you are to that, right? So you guys are like, yeah. What about this? What's log base 4 of 1? Again, it's all about what is the question that's asking you. Yeah, the question is, what do you raise 4 to make it become 1? Yeah. Anything to the 0 power is 1. So the answer here is 0. That's some crazy shit. So please don't make, I don't know if you guys are with me yet or not, but logarithms are nowhere near as hard as people make them out to be. They are nowhere near as hard. People just assume that they're difficult because you've never seen a symbol that's basically a freaking word. Unless you've ever seen trigonometry where you got SIN for sine and COS for cosine, all that kind of shit. It's the same kind of thing. If you've never seen that before, don't freak out. We're not going to do it. Unfortunately. Couple more real quick, and then I got all a handout like I always do. What's log base b of b cubed? This one's almost too easy. The answer's staring you in the face. 3. What do you raise b to make it become b to the 3rd power? Well, you just answered it as you said that, right? It needs a 3rd power to become b to the 3rd power. Now, in one way, why does this make sense? Because a logarithm is the opposite of an exponential. So log base b is the opposite of b to a power, so these cancel each other out. Freaky. Let me think. What else is kind of weird? What about this? What's log base 2 of 1/4? I like that. What's log base 2 of 4? 2. And then you need the power to make it flip. And of course, what kind of power makes things flip? Negative. So it's negative 2. 2 to the negative 2 is 1/4. Check. So really all it is, it's about internalizing the question. Now, of course, you have to understand how exponents work, but that's got to be an assumption that you do. And then once you do, then it's all about what question is this really asking. So here, let me give you guys this here. There's some problems. There's a graphing problem, and there's some problems at the bottom. And I've got a bunch of explanation in the middle if you want to read through that. Make you feel better about writing all that words and read.